Assalamu alaikum wa rahmatullahi wa barakatuh. Last video, we uh, introduced the idea of how to name and how to recognize the group of compounds that are called carboxylic groups. And we said that any compound that contains carboxylic groups, carboxylic acids or compounds, contains COOH group as a functional group. And we also said that we have another homologous series which is called alcohols, and they have the functional group OH functional group. So what happens if a carboxylic acid and an alcohol reacted together? For example, if I have an alcohol like CH3OH, we are going to give this compound the name methanol. And we are going to add a carboxylic acid like CH3COOH, which is called ethanoic acid. So, for this reaction, there is a catalyst required in order to complete this process, which I'm going to give the name for the process at the end of the equation. But for now, we need concentrated sulfuric acid, and this substance is considered in this reaction as a catalyst. So, if I'm going to write the structural formula for this compound, or for each of the two compounds we have here CH3, and the functional group is OH, so it's an alcohol. And we are going to write the acid, the ethanol, as you can see. So we said that when they are reacted together, we have the OH group and H from the alcohol joined together to form water. And the rest of the compound forms what is called an ester. Like this. So this type of compounds that contain the functional group C double bond O, this type of compounds is called esters. So in this case, we have this compound belongs to esters. And the name of the compound, we have two ways to name this compound. So I highlighted this part, this functional group, and this one, this group, C double bond O, is called ester group. And the rest of the compound, if you can see here, we have here one carbon atom joined with 3 hydrogens, and we have here another carbon atom joined with 3 hydrogen atoms. So, if we said that this is a methane compound but minus hydrogen atom. So for methane, we have the methane gas. It's one carbon joined to 4 hydrogens. If I'm going to remove this hydrogen, so the rest of this compound is called methyl group. So whenever you have an alkane that has -1 hydrogen, So it's called "-ile". We add the suffix "-ile". So we have here methyl group. We have here another methyl group, and in between there is an ester linkage. So we can call this compound dimethyl ester. This is a method that we use for naming, but the corrected method, or the official method, or the method that we use in our curriculum is we called the ester for the names of alcohol and carboxylic acid used to form this ester. By mean, I have here methanol, and when I remove the H from methanol, it's called, or it takes the suffix "-ile". So it is methanol, it's methanol. If you remove this hydrogen, it turns to be methyl. So we're going to name this methyl after removing the H. So we have here methyl. And by removing OH from the acid, we give the suffix, or we change the suffix from anoic, like in this case it's ethanoic. We change the suffix from anoic to anoate. So it's ethanoate. So finally we have the ester methyl ethanoate. So whenever you have an ester, and you want to call the ester, look for the alcohol you have. It's methanol. So when it turns to be an ester, it turns to be methyl. If it's ethanol, so it would be ethyl. If it's propanol, it would be propyl. If it's butanol, it would be butyl. When we remove the hydrogen. And for the carboxylic acid, when we take the OH from the acid, it turns to be anoate. If it's methanoic acid, it would be ethanoate. Ethanoic acid, it would be ethanoate. Propanoic acid, it would be propanoate. Butanoic acid, it would be butanoate. And we write both names together. So in this case, we have here the methyl ethanoate compound. It's methyl ethanoate compound for esters. And this whole process has a name, which is, or this process, we give this process the name condensation process. We have here condensation. It's called condensation. When I mention the term condensation in chemistry, I mean I'm going to join two compounds together by removal of water. I'm going to take OH from this compound and one H from the other compound to form water. And the remaining parts of both compounds are going to join to form a bigger compound. This process is called condensation process. This is a chemical process when two compounds join together by removal of water. And it doesn't belong to the idea of condensation of water in the physical change. For physical changes, condensation means changing of water from the gaseous state to liquid state. But this is a physical change. But in chemical changes, condensation means joining two compounds by removal of water. 4. So, here we have a question arise. Can we use this idea? Can we use this idea to form polymers? Yes, of course, we can use this concept, this condensation idea, to form condensation polymerization. To revise the term polymer, polymer is a large molecule. We call it macromolecule. It's a macromolecule. Polymer is a large molecule or a macromolecule that is formed from joining smaller units, sorry for that, called monomers. Like the beads, if I want to have beads, like the bracelets that we used to wear, so I'm going to bring one bead and join it with another bead and join it with another bead and so and so and so until we have larger structure from these smaller units. We had the first type of polymerization, which is the addition polymerization, and you can remember that when two units have double bond, and we're going to join these two units by adding one unit to another by breaking this double bond, then forming larger compound. The other type of condensation of polymerization is the condensation polymerization. And here I'm going to refer to the monomer with this box, and it's okay to give the molecule you have this shape. This is the remaining of compound, and we don't need to write all the carbons and hydrogens exist in the compound. We have here for example 2 carbons, 4 hydrogens, for example. It doesn't matter for me. The main concern for me, the existence of 2 OH groups. This is the functional group, and we have to focus on the functional group we have here. I'm going to refer to this compound to glucose. Glucose, I'm going to refer to glucose by this structure. If we have here 2 units of glucose, I have here another unit of glucose. This is also glucose. If we added 2 units of glucose and we had a catalyst like concentrated hydrochloric acid, what will happen? I'm going to take OH from unit and 1H from the other unit in order to form water. And I'm going to write the remaining parts of the molecule. We have here 2 units. In between them, we have oxygen atom. And we still have OH here and OH here. What happens if we added another glucose unit? Still has OH and another OH. So we can remove OH group from this unit and H from the other unit to form water. And we're going to have 3 units joined together. And we can repeat this step so many times in order finally to form starch or carbohydrates. So, whenever you ask yourself how plants can make starch or carbohydrates, the food type that we use in our diet to support us or to give us the energy we need. The plant use glucose molecule and another glucose molecule and join them by condensation. Like this case, we have here glucose unit and another glucose unit, and by using a catalyst like concentrated hydrochloric acid or implant by using different enzymes, these two units are going to join together by removal of water and form two units of sugar attached. If we brought another molecule, going to have three units attached. By repeating this step so many times, we're going to have the starch. So, if whenever I ask you what's the monomer of carbohydrates or starch, the monomer is glucose. How the units of glucose are attached together by using a catalyst or an enzyme to form or to make the condensation process by removal of water, joining different compounds by removal of water, then adding another unit and another unit and another monomer and another monomer, and enlarge the molecule to have a polymer or a macromolecule, which is called a polymer. And this method used is condensation polymerization. So, do we have the ability to make this with other compounds rather than the glucose? Of course we have. Let me give you an example for a synthetic material that we use in our life, which is the polyester. Here in Egypt, we name this type of compounds the polyester. Polyester, which is the informal way we called polyesters. Polyesters, can you tell me how the esters are formed? Yes, if we revise the video from the beginning, we said that we have alcohol and carboxylic acid. When we add a catalyst, we can get ester and water. So, what if we have a unit that has double OH and we used another unit, another monomer that contains two carboxylic groups, like this. So we have here a monomer which is called diol because we have two OH groups, and this unit is called dicarboxylic. Dicarboxylic because we have two COOH attached to the compound. If we have here a catalyst, what will happen? We're going to take OH from this unit and H from this unit to form water. Water is eliminated. And what will be the remaining? We're going to have here C double bond O and O, and unit has OH from this terminal and C double bond O, OH from the other terminal. Can we repeat this step once more? Yes, if we had an alcohol here, diol, like this, and we have a catalyst that can remove H from the alcohol and OH from the acid, another water molecule will be formed, and we have the rest of the molecule, O, C double bond O, C double bond O, and another molecule, and we have here the functional group C double bond O that refers to the ester. So we have here one ester and one ester, and we can repeat this step once again by adding dicarboxylic, another ester group will be formed, and another ester group will be formed, and another, till we have a polyester. So this is called polyester. We can name this polyester tyrylene or tyrylene. Tyrylene or tyrylene. Tyrylene or tyrylene is a polyester that's formed from monomers that one is diol, one monomer is called diol, and the other is called carboxylic. When we add the two compounds together in the presence of a catalyst like concentrated sulfuric acid, this will remove N water, whatever the number of dicarboxylic and diol we have. We have here a lot of water molecules removed and different units and a lot of units that are formed, which is called polyester or tyrylene. This is a synthetic polyester. This is a man-made. So we have an example in our diet that is made naturally. The plant or the living organisms can form, which is also considered as polyester, natural polyester, which is called fats or lipids. And if you remember, sorry, it's fats. Okay, if you ask yourself, what are the products of the digestion of fats or lipids? I know that you're going to tell me the products are fatty acids and glycerols. So if I had a type of fat or type of oil or type of lipid entered my body, I have some enzymes that are going to break down this fat or lipid or oil into fatty acids and glycerol. So if we can reverse this process, so we are going to have glycerol plus fatty acid in the presence of a catalyst. Of course, we will have fats or lipids. Okay, what would be the structure of glycerol? Glycerol is an alcohol that formed of 3 carbon atoms, and we have 3 OH groups, and the remaining of the molecule is hydrogen. So if you want to write the glycerol, so write 3 carbon atoms vertically, join to them 3 OH groups, and fill the other carbons, the remaining bonds of the carbon, with hydrogens. And we are going to add 3 molecules of fatty acids, and we are going to refer to the fatty acid to a box, and this box, once again, like in math, unknown, NX. Okay, we have here a lot of carbons and hydrogens. Okay, to make it short, to cut it short, if I'm going to write the complete structure of a fatty acid, we have here, for example, this C17H 35 COOH. This is a fatty acid. And instead of writing C17H35 COOH, I'm going to replace this part with this box, C double bond O OH. I'm going to replace this C17H35. No need to write all these carbons and hydrogens. So I'm going to give them this symbol, this box, a unit, number of carbons and hydrogen. Okay? And we have here a third fatty acid, C double bond O OH. Those are fatty acids. and this is called glycerol. By adding a catalyst like concentrated sulfuric acid or phosphoric acid, we are going to remove 3 water molecules. 3 water molecules are going to be formed because we have here 3 carboxylic acids. We're going to remove this OH and this OH and this OH with 1 hydrogen, another hydrogen, and another hydrogen. So how many water molecules are formed? We have here 3 water molecules. And what would be the remaining? We have here 3 carbons, like this. Hydrogens, the remaining hydrogens, and we remove here hydrogen, so there is oxygen atom remains. We have here hydrogen removed and we have oxygen atom remains and another oxygen atom remains, and we are going to write the remaining parts of the acid. We remove this OH, so we have C double bond O, so we add to the molecule C double bond O and another C double bond O and another C double bond O, so we have here a fat or lipid. Why we called this natural polyesters? Why we said that these compounds are natural polyesters? Because we have here 3 ester linkages. So this fats and lipids are kind of polyesters. All right. So let's have here stop for this part, and the next video we will talk about something reverse to the condensation process, which is the hydrolysis. The opposite of condensation is the hydrolysis. If we said that condensation is joining 2 monomers or 2 compounds by removal of water, so the hydrolysis means breaking down of large molecule into smaller molecules by adding of water. So we will discuss this part in the next video, inshallah. Thank you so much, and I hope you enjoyed.